Okay, last time, ang diniscuss natin ay uh, energy. Okay, we discussed about conservation of energy, the loss of uh, conservation loss ng energy. And then towards the end, dinescribe din natin yung um, potential, specifically on how it can be used to describe yung motion ng particle. Because potential is essentially ang tawag dito, related to the external force. So sinabi natin na if we know the potential of a particle, then we can predict kung ano yung magiging motion ng particle. And we can do that by determining, for example, yung points or in mathematics, di ba? In Math 53, points of inflection or turning points pagdating sa physics. So, yung mga points of stability. Okay, and to get the points of stability mathematically, we take the first derivative and set it to zero and determine yung positions kung saan nagsi-zero yung first derivative. And then, sinabi din natin na malalaman din natin kung unstable or stable yung equilibrium position. Depende sa second derivative. If the second derivative is positive, then we know that the position is curving upward. That is stable equilibrium. On the other hand, if it is negative, then it's the curve is curving is arching downward, and yung position na yun is unstable. Okay, so let's consider now an example. Okay, let's consider this example 2.12, and an example on how to apply yung concepts ng equilibrium na yun using yung potential. So let's consider the system of pulleys as shown. May dalawang masses M1 tsaka M2. Tapos merong string that connects these two masses. Okay, at yung string na yun ay may total length siya. Tapos the string passes under yung pulley na ito at and then over this pulley at point B. Okay, yung distance between point B at saka itong point A is 2D, and another pulley with mass M2 is attached over the string, pulling it down between A and B. Okay, so somewhere here. Okay, hinihila ng M2 yung pulley pababa. Okay, so calculate the distance x1 when the system is in equilibrium. So itong kinakalculate natin kung kailan equilibrium yung system, and determine whether the equilibrium is stable or unstable. Okay, so to do that, syempre, kailangan muna natin malaman yung expression for the potential. And how do we get the expression for the potential? Since dalawa yung ano dito, dalawa yung masses dito, we can sum their potentials to get anong tawag dito, total potential. First, yung potential due to M1 is mg x1 if we refer to this point. Okay, so ang reference natin is this point. Reference position. So at the reference position, we say UB is equal to UA is equal to 0. Okay? And then yung U2 naman ay of course it's negative. Yung U2 naman is negative M2G X2. Okay? So medyo straightforward naman yan. Yung X1 is the variable, is the dependent variable or independent variable na hahanapin natin para malaman kung nasan yung equilibrium position. X2, we need to relate it to X1, right? Okay, now, if this point here and this point here has a distance of 2D, and this is X2, okay, so ito yung X2 natin, okay. Itong C na to is just a constant. It just describes yung distance from the pulley to M2. And notice that we're not considering yung radius ng pulley, di ba? So like for example, itong x2, distance yan from here to here. Okay, so wala tayong pakialam sa radius. And yung x1 is the distance from here to here. So wala tayong, again, wala tayong pakialam sa radius ng pulley. Okay, so we consider them as point particles. Okay, yeah, what do we do here? Ang gagawin natin dito ngayon ay hanapin natin yung x2 in terms of x1. So how do we do that? So itong total distance ng string, okay, total distance ng string na to, let's say it's x for example. Okay, and that total distance, okay, from here to here, so nabawasan na 'yon, di ba? Sorry, total a light string of length b. So ang total length pala ng ano ng string is b. So kung ibabawas natin yung x1 from b, so b minus x1, ang b minus x1 is this, length from here to here. So yung length na yan. Yan yung b minus x1. Okay? And obviously, pag divide natin yan, that's b minus x1 over 2. Which means na itong distance na to from here to here is b minus x1 over 2. Tsaka itong distance na to from here to here is b minus x1 over 2. Now, we know x2 to be this one, and this is of course d. Diba? So we can use Pythagorean's theorem to relate x2 with x to x1. So so ano ba to? db minus x1 over 2 squared plus x2 squared is equal to d squared. Okay, and if we isolate x2, then we have x2 is equal to square root ng b minus x1 squared over 2 minus d squared. Okay, so yan ang ating x2. And then we put that here. So which means na u2 is equal to negative m2g square root ng b minus x1 squared over 2 minus d squared, which means na yung total potential in this case is negative mgx1 minus m1g1, m1gx1, m2g times b minus x1 squared over 2 minus d squared. Okay, so this is what we need to evaluate. Okay, or what we're going to use. Itong expression na to for the potential dependent on x1 is the potential that we need to evaluate. Okay. Okay. So para makuha natin yung equilibrium position, we take the derivative of u with respect to x1. Okay, so let's just rewrite u here again. Minus m1g x1 minus m2g square root ng b minus x1 squared over 2 plus or minus d squared. Okay. And then, oops, nakalimutan natin tong c na to, no? So, minus m2gc. Kailangan natin isama yung c kasi yung potential is the distance from ng m2 with respect to the reference. So, dapat kasama yun. So, minus m2gc. Of course, it doesn't really matter kasi pag kinuha natin yung first derivative, okay, with respect to x1, then that last term just simply cancels out. So what we have here then is negative m1g minus m2g over, okay. So meron tayong square root doon, so positive 1/2. Okay, then syempre yung square root mapupunta na sa ilalim, b minus x squared over 2 minus d squared. Okay, and then use chain rule. So we have 2 2 times b minus x, and then yung negative sign na coefficient ng x. So this becomes plus times 2 b minus x. Oops, nakalimutan ko yung 4 sa ilalim. So b minus x over 4. Itong 2 na ito. This is squared. Okay. Parati kong kinakalimutan. This should be 4. Squared dapat yan. So, kasi b minus x1 over 2 yan. So this should be 4. Okay. 2 squared. Okay. Okay. Yun. So, magka-cancel ngayon itong 2 dito, tsaka yung 1/2 doon. And then we are left with this expression equal to minus m1g plus 1/4 m2g b minus x1 over square root ng b minus x1 squared over 4 minus d squared. Of course, x1 is evaluated at x naught. Okay. Yung x naught ay yung equilibrium position. Okay. So we set this to 0. Okay, and determine x naught. Okay, so anong makukuha natin dyan? If we set that to 0, then we get m1g square root ng b1 minus x naught. Pinalitan ko na yung x1 ng x naught over 4 minus d squared plus 1/4 m2g b1 minus x naught. Okay, equal to 0. Okay, and then kinalimutan ko na yung denominator because we're just taking the numerator and then setting that to 0. Okay. Okay. Ano nang mangyayari dito ngayon? We solve for x naught, right? So solving for x naught, then we get. So pwede nating ilipat ito sa kabilang side. Okay, so 1/4 m2g b minus x naught equals sa m1g square root ng b minus x naught squared over 4 minus d squared. Of course, if we square all of that, then we get 16, 1 over 16, m2 squared, g squared. Pwede na natin i-cancel yung g, by the way. B minus x naught squared is equal to m1 squared, then b minus x naught squared over 4 minus d squared. Okay. Then solving for x naught, what do we get? So meron tayong 1 over 16 m2 squared dito, and then dito naman may m1 over 4 tapos m squared dun. So 1 over 16 m2 squared minus m1 squared over 4 times b minus x naught squared equals sa negative m1 squared d squared. Okay, and if we simplify that, okay, so continue lang natin dito. 1 over 16 m2 squared minus m1 squared over 4 b minus x naught squared is equal to negative m1 squared d squared. Okay, multiply everything by 16. Okay, or negative, gawin natin negative 16. So we have m1, 4m1 squared minus m2 squared times b minus x naught squared is equal to 16 m1 squared d squared. So b minus x naught squared is equal to 16 m1 squared d squared over 4 m1 squared minus m2 squared, or b minus x naught is equal to 4 m1d over square root ng 4 m1 squared minus d squared, or x naught is equal to b minus 4 m1d over square root ng 4 m1 squared minus d squared. Okay, so yan yung ating x naught. Okay, now, how do we make sense of this solution? Okay, so kailan, oops, anong ginawa ko? m1 over m squared. m2 squared. Okay, now, this solution will only make sense if yung denominator is, anong tawag dito is, well, if this whole solution is real, so it has to be real, right? The only way that it's going to be real is that if 4m1 squared is greater than m2 squared, okay, or m1 is greater than m2 over 4. Okay, so and that will be the condition for equilibrium. So m1 must be greater than m2 over 4. Okay. Okay, so yun yung ating condition for equilibrium. Okay, now is this a stable or unstable na equilibrium? Okay. So to determine that, we take the second derivative and then we start, of course, from here kasi ito yung first derivative term natin. Okay, to get the second derivative, okay, we start with that, negative m1g minus m2g b minus x1. Sige. So u du dx 1 is equal to negative m1g, okay, plus m2g b minus x naught over times 1/4 square root ng b minus x naught squared over 4 minus d squared. So we take the second derivative, then we get so negative, wala na, of course constant yan, so wala na yan term na yan. Then we just simply get, we use the chain rule, so 1/4 m2g. Okay, so we have b minus x naught, so negative negative x naught, so negative 1. So negative 1 over square root ng b minus x naught squared over 4 minus d squared. Okay, plus b minus x naught, okay, times negative 1/2. Okay, sige, plus muna yan, times negative 1/2. Okay, then this becomes b minus x naught squared over 4 minus d squared, 3/2. Then we use chain rule, so we also have 1/4, and then negative, and then 2 b minus x naught, and then of course negative 1. Okay, hindi to x naught kundi x1 kasi we hindi to equilibrium na x1 lahat yun. Okay, so and of course we need to simplify that. Okay, simplify muna natin. So d squared u dx1 squared is equal to 1/4 M2G, okay, -1 over B minus X1 squared over 4 minus D squared minus or plus ito, tapos may -1/2, +1/4, di 1/8, may 2 ka dyan, so this cancel with this, then cancel yung negative sa negative, so you'll end up with plus 1/4 B minus X1 squared over B minus X1 squared over 4 minus D squared, and then square root. Okay, square root. It's not just the square root, but the cube root. Okay. Yeah. Okay. So, gusto natin malaman kung ano yung stability, di ba, at the equilibrium position. So, we replace x naught with x1 with x naught. Now, x naught is b minus, so replace x1 with x naught, and x naught is equal to b minus 4 m1 squared d squared, 4m1 over square root ng 4m1 squared minus m2 squared. Okay. And of course, na-derive naman natin ang b minus x1 earlier is, na-derive natin earlier na ito ay equal sa 4m1 d over square root ng 4m1 squared minus m2 squared. And if we're replacing x naught by x1, so this becomes x naught. So lahat ng mga ito, ito, ay i-replace natin with this. Okay. Actually, since squared yan, so b minus x naught squared is just 16m1 squared d squared over 4m1 squared minus m2 squared. Okay, so i-replace natin lahat ng blue na yan with lahat ng blue na ito. Yung circle ko na blue with this. Okay, and when we do that, so we have 16 minus m1 squared dito, 16 minus m1 squared d squared dito, 16 minus m1 squared dito, and then yung denominator na 4m1 squared minus m2 squared dyan sa mga blue na yan. So I don't want to go through all the steps kasi meron pa tayong kailangang i-cover. Okay, so minus 1/4, we'll just end up with minus 1/4 g m 4m1 squared minus m2 squared raised to the 3/2 divided by m2 squared d. Okay, d squared dx1 squared evaluated for x1. Yeah. Okay, and since 4m1 squared is greater than m2 squared, then that means that this term is always positive. Okay, which means na yung second derivative nito is positive, and this position x naught is a stable equilibrium. And you can, of course, you can verify that by plotting itong graph, itong equation na ito. If you plot this equation, so plot u of x, okay, versus x, okay. Okay, you'll get some quadratic equation somewhere. Okay, na kung saan yung minimum na quadratic equation will be just equal to the equilibrium position and it's curving upward.